Welcome to Chemistry Lab. Today we're doing the penny density lab, and we're looking at the data collection sheet. Here we would need the names of the lab partners involved, the date the experiment is performed, and here's some data we need to collect on the digital balance that we'll be using. I see brand name, description, model number, serial number, maximum mass in grams, and resolution in grams. So let's try to find the brand name first of all. Well, here's the balance I'll be using, and I see the brand name is Carolina. So I would write Carolina here for brand name. Description, color, etc. Well, I would say the color would be blue and light gray. And it has a plug that plugs into an outlet, so I might put some of that there. Model number, if any. Well, I don't see a model number on the front. Let's look on the back. Model SLB152. Okay. Let's see if I can set that down. There we go, now it's sharp. Model SLB152. Okay, so I would write that here under model number. Serial number, if any. Well, looking back over here, I see a barcode, serial number 83400903322. That's the serial number of this digital balance. So I would write that here where it says serial number. Maximum mass in grams. Well, as long as we're looking at the belly of the beast here. Maximum, see where it says maximum 150 grams. Okay, so that would be our maximum mass we can measure. And the resolution in grams. Well, it actually has it back here as well. D, 0.01 grams. We can also figure that out by looking at the display. So let's go ahead and flip this back over. And everything is out of focus. Let me put it back into automatic focus here. There we go. So I'm going to plug it back in to the power. Flip that up. Go ahead and turn that on. We're getting a big time glare off of the overhead lights, which can't be helped, I guess. So it's going through its self-calibration. Now it's 0.00 grams. So right there is how you could tell the resolution would be 100th of a gram. So the resolution here is 0.01 grams. That's the smallest amount you could measure on here. Or better yet, that's the smallest difference in mass that can be measured. Okay, so we see we're in grams, so that's good. We have filled out everything we need on the digital balance. Now we are also using a graduated cylinder. So let's look over on our other table and see what we can figure out about the graduated cylinder. Okay, so brand name, if any. Let's look on here for a brand name. Not really seeing one. We may have to punt on the brand name. Yeah, not seeing one. Okay, description. Well, I can tell that it's a plastic graduated cylinder. Model number, there is none. Maximum volume, there we go, 100. You can see the 100 right there, 100 milliliters. And it also says that there, 100 milliliters. Temperature markings, if any, well, see that 20 degrees C? That means the readings on this graduated cylinder are accurate if the temperature of the liquid is 20 degrees C. Well, we're going to be a little warmer than that, but it doesn't matter for our purposes. Okay, resolution in milliliters. Okay, kind of hard to see there because there's a water droplet, but 100:1, that 1 is the resolution. You could also figure that out by looking at the scale here. You see the 90 and you see the 100, that's 90 milliliters and 100 milliliters. Every little mark in between those two must stand for 1 milliliter. So the resolution on this graduated cylinder is 1 milliliter. That means we should be able to estimate to 1/10 of a milliliter, which you'll see us do that shortly. Okay, so I think we've answered the mail here. Resolution, temperature markings, maximum volume, model number we couldn't find, brand name we couldn't find either. Okay. Now we're going to look at the description of a random penny, year and design on back. Well, let's go get us a random penny from our stacks of pennies here. Let's pick one off the top. Okay, that on the back is Lincoln Memorial. Lincoln Memorial. On the front, it's kind of corroded a little bit. But the year of the penny is 1987. 1987 Lincoln Memorial penny. So we could add that back to our stack. We'll write that down here. Description of random penny. Okay, we know the year, we know the design on the back, and it's kind of cruddy looking, kind of dirty. Initial volume of water in the graduated cylinder. Well, how many milliliters is in here initially? Okay, I'm going to put that up against a white background, make it easier to see. Okay, we can see that there's 50 milliliters, there's 60 up there, and down here we've got to use our judgment. It looks to me like it's 56. Let's see if I can point. That line there is 50. That slightly longer line there is 55, and there's one more short line above it, which would be 56. But it's above 56. It's between 56 and 57, and it looks like it's about halfway between the two. So I would call this 56.5 milliliters. So let me write that here. Yeah, 56.5. Whoa, you haven't enjoyed life until you can write and hold a camera at the same time. 56.5 milliliters. That's our initial volume of water in the graduated cylinder. So now we're going to go visit our stack of 10 pennies. And our first stack, we're going to measure the mass of it, and then we're going to put those 10 pennies in that graduated cylinder and measure the volume of that stack. So I'm going to stop the camera while I go get those 10 pennies. So what I'm going to do is I've got an empty cup that I'm going to use for transporting my stack of 10 pennies. And I'm going to put it on the balance, and I see it has a weight associated with it. Well, I'm going to zero the balance based on the weight of that little cup. Let me back out a little. So this is called tare, T-A-R-E. I'm going to tare the balance with that cup on it. So now the balance thinks that cup has a mass of 0 grams. Now when I put pennies in there, it will properly show the mass of those pennies. So I am going to take the cup off, put in my first stack of 10 pennies, put it back on the balance, and I get a mass of 25.13 grams. Come over here. 25.13 grams. I'm writing on some tape or something underneath there. Okay, so our first stack has a mass of 25.13 grams. Let's go put those in the graduated cylinder and see what our water level rises to. Okay. All right, I'm going to try to do something with this camera here so that we can actually use two hands. Okay, this should work. So I've got the cylinder. And let's get focused on the cylinder and not on that poster in the distance. There we go. So I'm just going to tip my graduated cylinder at about a 45-degree angle and slowly dump these pennies in, trying not to splash. Okay, there went in the 10 pennies. Okay. Now, to get rid of some of those air bubbles, you can maybe see some air bubbles down in there. I'm going to tap like I'm burping a baby. Try to get all those bubbles out. Okay, now that they're out, I'm going to read the volume on the graduated cylinder. Okay. Okay, so it looks like we did, well, there's a droplet of water there. So it looks like our volume is now, ooh, that is pretty much exactly 60, I would call that 60.0 milliliters. 60.0 milliliters. Okay. 60.0 milliliters. Okay. Now let's do it with the next 10 pennies. Let's put that back on there and make sure we're still at 0. And let's go ahead and re-zero that. Okay, 0 with the cup on it. Let's get the next stack of 10 pennies. There's our 10 pennies. Now we're going to get the mass there. 25.05. 25.05. Okay. 25.05 grams. And now let's take these pennies and go dump them in the liquid on top of the pennies that are already in there. So we're putting in 10 more pennies, and I'm going to try a different approach. I'm going to let this kind of hang off the end of the table and hold the cylinder like this, tip it sideways, and then just let those 10 pennies kind of slowly slide in. That was a much better delivery than last time. Okay, so now we've got 20 pennies in there. Let's tap on it a little bit to get rid of all the air bubbles as best we can. And come over here and get our next volume measurement, which is looking like, well, there's 70. So that line right there, okay, there's 70. That line, the longer line would be 65, so it's 63. I am thinking that's going to be 63.4. 63.4. Okay. 63.4 milliliters. Okay, now we're ready for our third stack of pennies. Let's put our little cup back on the balance, make sure it still reads 0. Well, let's re-zero it there. Okay, 0, 0. Putting in our third stack, 5 pennies. I'm sorry, 10 pennies. Now let's determine their mass. 25.04. .04 grams. I forgot to put grams up there. 25.04 grams. Now we need our volume. So I think that worked out pretty well, hanging my camera over the edge like that. Okay, there's our graduated cylinder. Let's tip it down. Don't tip it too far, otherwise the liquid will come out, but let's slowly dump our pennies in there. Okay, and again, we already have 20 pennies in there, so here comes the next 10. Oh yeah, those guys went right in there just like they should have. Okay. Tap it a little bit, get rid of air bubbles. Let's get a volume reading. Looks like it's between 60 and 70. Okay, I'm reading 60. Well, there's 70, 69, 68, 67. Looks like it is right on 67. So I'm willing to call it 67.0. 67.0. 67.0. milliliters. Now we need the mass of our next set of pennies. So let me put our empty cup on there to make sure it's still 0. There we go. That, set it there. The next stack of 10 pennies. Let's get the mass. 25.07. 25.07 grams. And let's add this to the cylinder. Here's our cylinder that already has 30 pennies in it. We're going to add 10 more. Nice and slow. This would be so easy if we didn't have to video it. Okay, there's all 10 pennies in there. Now let's kind of tap on it. Get all the bubbles out we can. Let's take a volume measurement. Okay. So it looks like we're slightly greater than 70 milliliters, but not quite 71. Let me steady my hold here. It looks like it's closer to 71 than it is to 70. I'm going to call it 70.7. 70.7 milliliters. .7 milliliters, and now we're on the last stack of 5 pennies. Let's first set that cup on there to make sure it's zeroed still. All right, we can zero it. Well, it was zeroed. I guess I didn't need to zero it, but wouldn't hurt. Okay, now let's take the cup, get our last stack of 10 pennies, put them in there, put it back on the balance, and surprise, surprise, 25.02 grams. Grams. Now we need the volume. Okay, there's our cylinder that already has 40 pennies in it. So I'm going to set this on the edge. Bring my cylinder over here and then tip it down a little bit so these pennies won't splash too much, and put in the last 10 pennies. Okay, there they are. See? Empty cup, no more pennies. But I still see some bubbles in there, so let me tap. Yep, you can see some bubbles flying around. There's some kind of bubble or something right there. It's a dark object. Oh, that's actually on the outside of the graduated cylinder. I thought it was inside. Okay, so we got to go make a volume measurement. Okay, we're getting up there in volume now. So there would be, looks like there's 80. That big line is 80. Come down to that slightly longer line, that would be 75. It looks like it's down at 74. And is it exactly 74? I think it's maybe a little higher than 74. I would call it 74.1. 74.1. So let's call that volume. .1 milliliters. Okay, we now have all of our mass data and all of our volume data. And now record any relevant observations here. Well, I won't write them down here, but what I noticed was some of the pennies looked pretty cruddy, like corroded a little bit. There may or may not have been residual air bubbles in there. I'm not sure. Another observation was the water apparently had some blue coloring added to it. I don't think we splashed any water out of the graduated cylinder, but if I felt water on my fingers as I was sliding those pennies in, I would know that some water splashed out of the cylinder, but I don't remember feeling any water. So I would write down, the relevant observations here, and then I believe that is all the lab data that I need to collect. I will need to do something here. We know that if I put 10 pennies in, we can figure out the total volume Okay, that's on our data sheet. And then the total mass, well, that would be the mass of the first 10 pennies. When we have 20 pennies, we can write the volume here. And then what is the mass of the first 20 pennies? Well, we would have to add 25.13 plus 25.05 grams. Okay, then when we have 30 pennies in the cylinder, we can just write down the total volume. And then here, total mass of the pennies in the cylinder. We'd have to add 3 numbers to get that. We'd have to add 25.13, 25.05, and 25.04. So that's how that works. And then from that, we can finish writing up our lab. So I think I'm going to call it a day. Goodbye.